Hello everyone, this is Katish here. In this video, I'm going to go through the AQA GCSE Chemistry Paper 1 Higher Tier from 2022. Question number 7 is on the topic of quantitative chemistry. This question is about silicon and compounds of silicon. The reactivity series sometimes includes non-metals such as carbon, hydrogen, and silicon. Silicon can be extracted by reducing silicon dioxide with different substances. The equation for one possible reaction is 2 carbon solid plus silicon dioxide solid gives or produces silicon solid and 2 carbon monoxide, which is gas. Explain why this reaction shows that the position of silicon is what this reaction shows about the position of silicon in the reactivity series. Now, silicon has to be less reactive than carbon for carbon to displace the silicon from the oxygen to form carbon monoxide. So if not, it's the carbon is not going to displace it. So what this reaction shows is silicon is less reactive than carbon because carbon displaces silicon from silicon dioxide. Aluminium can also reduces silicon dioxide. Carbon is used rather than aluminium to reduce silicon dioxide because carbon is cheaper than aluminium. Carbon can be obtained by heating coal. Aluminium is obtained from aluminium oxide. Explain why aluminium is more expensive than carbon. Now, if you want to get aluminium from aluminium oxide, you will have to go through the process of electrolysis. Now, electrolysis uses electricity, which is much more expensive than simply heating the coal to get the carbon. So you will need more energy, hence it's more expensive. More energy is needed to obtain aluminium because aluminium is obtained from aluminium oxide by electrolysis. We'll give you the 2 marks. Magnesium also reduces silicon dioxide. The equation for the reaction is 2 magnesium solid plus silicon dioxide solid again gives you silicon solid plus 2 magnesium oxide solid. Give one reaction why the products are difficult to separate if magnesium is used to produce silicon dioxide. Now, in the above process, when you're reacting carbon with silicon dioxide, the silicon, which is a solid, and the carbon monoxide is a gas, so that can easily be removed, so we're leaving just a silicon on its own. Here, if you react it with magnesium, because both of these products are solids, you will have to involve a different process to separate them out. So both products are solid, hence it's difficult to separate them out. Calculate the minimum mass in grams of magnesium needed to completely reduce 1.2 kilograms of silicon dioxide. So you're trying to reduce 1.2 kilograms of silicon dioxide. So if I rewrite this equation below, 2 mg solid, state symbols will be important. SiO2 solid gives Si or silicon, which is a solid, plus 2 MgO, the solid. So calculate the minimum mass of magnesium that is required. So you're trying to work out how much magnesium you will need in order to reduce 1.2 kilograms of silicon dioxide. Now 1.2 kilograms, let's convert it to grams, multiplied by 1,000 will give you 1,200 grams. So that way you can work it out in terms of ratios. So let's find the number of moles of silicon dioxide, because you have the mole ratio. 2 moles of magnesium is reacting with 1 mole of silicon dioxide. So molar mass of silicon dioxide is equal to, silicon is 28 as they have given here, plus oxygen is 16, because that's 216 times 2, that give you a molar mass of 60 grams. So 1 mole equals 60 grams. You're using 1200 grams, so how many moles is that? 1200 gram divided by 60 will give you 20 moles. So what you have, according to the equation, let me use a different color here. So what you have, 20 moles of silicon dioxide. Remember, the mole ratio is 2:1. So if you are using 20 moles, the number of moles of magnesium that you will need, number of moles of magnesium you will need is twice that of silicon. So 2 times 20, that's 40 moles. Now the molar mass of magnesium is 24. So 1 mole of magnesium is 24 grams. So 40 moles is going to be 24 times 40, that's 960 grams. 960 is your answer. Question 7.5, SiH6. Now that's a new compound that you haven't probably come across in terms of a name. It's called disilane. So DISILANE, that's what it's called. You don't really need to know the name. Is a covalent compound of silicon and hydrogen. Complete figure 9 to show the outer shell electrons in a molecule of SiH6. Now silicon is in group 5. Now you can use a periodic table, or you can work it out from here itself. Now let's say this part is actually full. Silicon is trying to bond with 3 other hydrogen atoms, so it's sharing, it should have 5, so it can have 3 more. So let's complete the, so let's say I put a dot for the hydrogen. So each of the hydrogen electron and actually the crossword would be the hydrogen, isn't it? So the crosses for the hydrogen, because it's going on the hydrogen ring, and you would have the dots here. So this is why it's important to decide if it's a cross or a missing. So 1, 2, 3, 4, 5 on the bigger ring, and just 1 cross in each of the smaller rings. SiH6 reacts with oxygen. The equation for the reaction is 2SiH6, which is a gas, reacts with 7 oxygen gas again to give 4 silicon dioxide solid plus 6 H2O gas. 30 centimeter cube of SiH6 is reacting with, so 30 centimeter is reacting with 150, which is an excess of oxygen. Calculate the total volume of gases present after the reaction. So after the reaction, how much is going to be present? So you will need to work out how much of the oxygen is actually reacting with this silicon SiH6, with this 30 centimeter cube of SiH6, and take that away from 150, so that will be the excess part that is remaining, and add that to the 6 moles of water that is also formed. So let's try and do that. So the volume of oxygen for 30 centimeter cube, so the ratio is 2:7. So if I simplify that, that will be 1:3.5, isn't it? So what is 3.5 of times 30? So the volume of oxygen needed to react with 30 centimeter cube of Si2H6 is equal to 3.5 times 30, that is 105 centimeter cube. So you will need 105 centimeter cube of oxygen. What you have is 150, so the volume of excess oxygen is 150 minus 105, which will give you 45 centimeter cube. So that's the volume of oxygen that you have. So that's only part of the answer. Let me use a different color here. Slightly bring it up again. Yeah. So the volume of water vapor the volume of water vapor ratio is 2:6. So that means that's 1:3. So if you have 30, if you have 30 Si2H6, then you will have 3 times that, which is 90 centimeter cube of water. So total volume is 45 plus the 90 will give me 135 centimeter cube. So the answer is 135. Now you could work that out in terms of moles as well, but it's a little bit complicated rather than actually trying to work it out in terms of ratios, but let me show you quickly the two answers which is accepted by let me see if I can bring it to the front. Bring it forward. No, doesn't work. Okay. Okay. We want that to happen. Let's see. How can I show the answers next to each other? I know how to show you. Oops, there you go. There you go. Those are the two different forms. This is the one that I showed you, the first one, and the second method is shown you here if you need. That brings us to the end of question number 7, I believe, and I will see you in the next question, which is question number 8.